Um, Hello everyone, welcome to this lesson. So in this lesson, we're going to go through the Python code for the Gauss elimination technique. Now, as I've explained in the previous lesson, Gauss elimination is a technique that is used to solve systems of equations. And we have introduced the 3x3 matrix in the previous lesson. And we have also explained that Gauss elimination has two primary processes. The first one is forward elimination, which we are eliminating three terms, more specifically the bottom left-hand side, the corner that we have here. And also with backward substitution, we're getting x3, x2, and x1. So in this lesson, we're going to be creating three code blocks. One to input the system of equation that we want to get a solutions for, and also another code block to do the forward elimination, and another to do the backward substitution. So let's begin. So here's the code for the Gauss elimination, and as you can see, we have three primary code blocks. This one is to input the system of equations, and here is to do the forward elimination, and here is to do the backward substitution. In terms of inputting the system of equation, we're going to be using the keyword array. Now, the keyword array is actually within the package NumPy. So for us to execute a lot of these keywords, we have to import the NumPy package. And from the NumPy, we want to import array and also zeros. Now, zeros is a keyword that can create matrices and vectors of zeros. And the great thing about this keyword is that you create the vector and matrices of zeros that you'll later in your code want to populate with solutions. So the zeros are placeholders. So here we're going to input first the augmented matrix A that we have here. Then we're going to be inputting the vector B on the right hand side. So if you can see here with A, it's going to be A is equal to array. And when you're creating a matrix, you're going to find it is actually a list of lists. And you can see we have the bracket on the far end here and the bracket on the far end. And you find that the first term here is a list, and this is our first row, comma, the second term is our second row, comma, the third term here is our third row. So you're going to find that this array is a list of three lists, each one corresponding with a row. In terms of B is just simply is made up of three numbers, so it's just merely a vector. So we're going to say array, and we're going to pass a list made up of -3, 2, and 1, and all of these are floats. Now also I want to define the n. N is basically the size of the system, which in this case is made up of three equations. So I'm just going to define it in terms of B. So I'm going to say it's the length of B. Now I want to finally create a vector for my solution. So x are my solutions. So x is equal to zeros, and I'm going to pass n, which in this case is going to be 3, comma, and I'm going to say these terms are floats. Now, which means when I run this x, is going to create a vector or a list of three elements. All of them are 0. So it's going to be 0, 0, 0. And again, those are placeholders for our x1, x2, and x3 as we progress through the code. Now, let's actually look at the forward elimination code. As you can see, it's actually made up of three different loops. We have a loop within a loop within a loop. We have the outside loop is a k, then the inside one is I, then the one further inside is j. Now k, you're going to find is 4k in range n minus 1. Now in this case, n is 3, so 3 minus 1 is 2. And we know for the range function, we go from 0 all the way to 2, but not including 2, which means we're going to be looping when k is 0, and we're going to be looping when k is 1. So it's going to loop twice. Now, the reason k is going to loop twice is because for the first loop of k, we're going to be eliminating those two terms and creating those two zeros. And for the second loop of k, we're going to be creating this third and final zero. So let's actually go through the first loop of k to create the first two zeros. Now here first, and we're going to say for I in range, we know k for the first loop is 0, so it's going to be from 1 to 3. And again, so we go from 1 all the way to 3, but not including 3, which means I is going to loop when I is 1 and when I is 2. Now, let's actually see when I is 1. So when I is 1, we have factor is equal to A10 divided by A00. Now, if you remember for Python, a lot of our indices start from 0. So here, this first element is actually A00, then this is A10, and this is A20. So when we're taking A10 divided by A00, what we're doing is we're taking 6 divided by 1. So we're creating the factor similar to what we have created here. Now, but then we're going to go into the j loop. So for j in range k to n, so basically it's from 0 to 3. So it's going to loop when j is 0, 1, and 2. So it's going to loop 3 times. So let's actually see what's going to happen in all these 3 loops. So we have a, and I here is 1. So a10 is equal to a10 minus the factor times a00. So if you can see from what we've done here, it took a10, which is basically 6, minus a10 times the factor times a00. So basically what we've done here, 6 minus this 1 times 6 is going to give us basically the 0x1 here. Now, if we go for the second loop, which is basically where j is equal to 1, so it's basically a11 is equal to a11 minus the factor times a01. So basically what we're doing here is basically 2 minus 1, which is the coefficient of x2 here, multiplied by the factor, which should give us -4. And for the third loop, you can predict that it's just going to take this term here, which is 2, minus this coefficient of x3, which is -1, multiplied by the factor, which is 6. So you can see this is what the j loop is doing. It's looping 3 times to create those 3 new terms that we have here, 0x1 minus 4x2 plus 8x3. So now that we have manipulated the a, let's go ahead and manipulate the b. So b here is going to be b1 is equal to b1 minus the factor times b0. So basically what we're doing here is 2 minus -3 multiplied by the factor. So now we have actually created this term, and now we have created or eliminated the first term and created our first 0 here. And you can predict that for the second I, so I here started 1, so when I is equal to 2, you can predict we're going to be creating the factor, and that factor is going to be the -3 divided by 1. And then after we're doing that, we're going to go into the j loop. It's going to loop 3 times, and it's going to do much like what we did here, and it's going to do the same calculations that we did here. So -3 minus 1 times -3 is going to give us this 0, and then it's going to be 4 minus 1 multiplied by -3 is going to give us 7, and it's going to do the same thing for the coefficients of x3, and it's going to give us -2. And once it's done with that, it's going to go through the b, and then it's going to get b2 is equal to b2 minus the factor times b1, which is basically 1 minus x3 multiplied by 1 minus -3 multiplied by -3, which is going to give us -8. So you can see this is for the first loop of k, and for the second loop of k, basically what we're going to be doing is the code is going to be running through what we have gone here. There is one thing that I want you to notice is the loops themselves. So here when k is equal to 1, you're going to find that we are here 2 to 3, which means I is only going to loop once. And the reason it's only going to loop once is because we're only getting 1 0 here, as opposed to the first loop of k where we were getting 2 zeros. Another thing that I want you to see is also with the j. So for j in range, k is now 1, so 1 to 3. So now it's going to loop when j is 1 and when j is 2. So the reason it's now looping only twice and not 3 times is here you can see that we were actually subtracting 3 terms from 3 terms, but here we're subtracting 2 terms from 2 terms. So that's why we're looping only twice in the j. So once this code goes through, we have actually created this forward elimination of our system of equations. So now we have what we have here. So now we go through backward substitution. And now with backward substitution, you can see that from this equation, this final one, that we can actually calculate x3. So what we're going to do is the first line of code in the backward substitution is basically getting x3. So it's going to be x3 minus 1, so 2, so x2. Now the reason this is x2 is, again, with Python, the index starts from 0. So when I created an x with 3 terms, the first one has an index of 0, 1, and 2. So when I am calling x2, I'm calling the last term where I want to store x3. So this is x2 is equal to b2 divided by a22. So basically, if you look at this matrix, b2 is basically the 27 here divided by a22, which is the 12, and this is basically going to create x3 for us here. Now we're going to go through actually this code here. Now, despite the fact that I'm using the keyword sum here, this is actually a subtraction code. Basically, what we're enacting is a lot of what we did with the x2 and x1. Now, before I go into the code, I do want you to see why I actually say this is a subtraction code. Is because if you notice, at least with the x2, you see that we took the b corresponding with the second equation, and we subtracted this term from it, right? We subtracted the coefficient of x3 multiplied by x3, and then after we subtracted this, we divided it by the coefficient of x2. And also, if we go to x1, you're going to find that we took the b, or the right-hand side, and we subtracted basically this term, which is the coefficient of x2 multiplied by x2 here, and then we subtracted the coefficient of x3 multiplied by x3. So this is what I mean by it being a subtraction code. And once the subtraction has been done, we divide it by the coefficient of the x value that we are after, so the coefficient of x1 in this case. So let's actually go down here. So here, I want you to look a little bit carefully on the loop itself. So here, for I in range n minus 2 to -1. So you're going to find if n minus 2 and n is 3, so 3 minus 2 is 1. So this is going to go from 1 to -1. So we said that with the range, it goes from 1 all the way to the last term, but not including the last term, which means it's going to loop when I is 1, and it's going to loop when I is 0. Also, if you have noticed, we're actually decreasing. And so normally the range by default increases by 1. So if we want to manipulate how the range function increases and decreases, we're going to have to put in a third term here. So since I wanted to decrease by 1 unit, I put -1 on the last term here. So as you predicted, here we got x at index 2. So x at index 1 is going to be corresponding to x2. X at index 0 is going to correspond to x1. So let's actually see how the subtraction code would go. So here I'm saying sum is equal to bi. So in this case, the first bi, so b1, and we know b1 is basically corresponding to the second equation here, so it's 2. And then minus, you're going to find here I have here aij and xj. So this is basically we're subtracting the 8 multiplied by 2.25. And after we have done this subtraction here, now like what I said, after we're done with subtraction, we divide it by the coefficient of the x we're trying to get. So xi, so in this case x1, is equal to that sum divided by aii. Okay, so it's going to be a11, which corresponds to the coefficient of x2 that we see here. So it's going to divide it by -4. So after this is done, so now we have gotten x3 and x2. We loop for the final one. This is where I is 0, and you're going to find that here we're going to equate the sum as b0, and then we're going to go here. Now the j here is going to loop twice, because for the first one is going to be subtracting this term, and for the second one is going to be subtracting this term. And after the j loop is done with this, then we're going to divide it by aii or a00, which is basically corresponding to this 1, which is the coefficient of x1. And at this point, we have calculated x3, x2, and x1. So let's actually go ahead and run the code. So first I'm going to run the package and get the array and zeros keywords, and now I'm going to run the code. All right, so perfect. So now that I have run the code, you can see that the solution of the system, so this is basically a display code that I've printed here. This is just a string. Think of it as a header. So I'm saying the solution of the system, and now I want to print x. Now remember, x is an actual list, so you can see that we have printed the list of three terms, x1, x2, and x3 as negative 0.25, negative 0.5, and 2.25, as you can see what we have here. So you can see the code is actually very, very simple. What's only involved within this code is just following what the loops are doing. But once you kind of get a grasp of what's happening within the loops, this is a very, very simple code to use. Now, in the next lesson, as you can see, this code actually I used, for instance, when I described n, I described it in the length of b, and also when I described x, I described it as n, and also a lot of the stuff in terms of n. So despite the fact that actually n here is 3, so this is a 3 by 3 matrix when we input it here, but actually this code can actually be used for any size matrix, whether it's a 3 by 3, 4 by 4, 5 by 5, 6 by 6 matrix. So in the next lesson, I'm actually going to go through multiple examples to show you how we can actually use this code for any size matrix, not only basically a 3 by 3 matrix. So kind of to recap briefly what we've learned in this lesson, we said that the Gauss elimination basically is made up of two main processes, forward elimination and backward substitution. And basically the code was made up of three code blocks. One was inputting the system of equation, one was going through the forward elimination, and one was going through the backward substitution. And we have actually went through that the forward elimination is a loop within a loop within a loop, where the K goes through two main loops, where the first one eliminates the first two zeros, and the second one eliminates the second zero. And once the elimination has been done, we already know the final x, in this case is x3, so we calculate that, and we have this subtraction code here that calculates for us x2 and x1. And again, this is, despite the fact that we have done this for a 3 by 3 matrix, this is a general code that can solve any size system of equation. The only difference is basically your inputting of A and B. So basically, in terms of, say, inputting a 4 by 4 matrix, all I'm going to be doing is this list is going to have 4 terms, 4 terms, and 4 terms, and then we're going to be adding another list of 4 terms that is going to be our fourth row, or our fourth equation. Well, that's it for this lesson, and I will see you in the next lecture. Thank you very much.